radiation of lambda by 2 dipole, or otherwise half wave dipole. Is there any other name for this one? Anybody? Please find it out. Another name is there. What is that name? That is important. Sometime exam they used to ask. What is another name of this one?
Doubt not, sir.
No, sir.
DOUGH.
ಇಲ್ಲ. Okay, and again, what is the polarization and everything? This is also linear polarization, because just I've extended the length. That's it. I've extended the length as compared to the previous one. So linear polarization, and again radiation pattern is also same, because just I have increased the distance, increased the length of the antenna. That's it. So polarization remains same, linear polarization, and then radiation pattern is omnidirectional. Okay, radiation pattern is omnidirectional. That means what? It will radiate uniformly in the horizontal plane, non-uniformly in the vertical plane, omnidirectional. Okay, linear polarization and omnidirectional antenna. Okay, now here also I'll choose some point, random point on the space. Okay, then I'll try to calculate what is E, what is H, what is E, what is electric field, and what is magnetic field. Okay, then once if you calculate the electric field and magnetic field, it will be like this. Finally, here also the electric field will survive only for E theta. Okay, the E theta value is equal to 60 Im divided by R. Please mute your mics, others. Mute your mic. Here I am putting Im. In the previous case, I put I. Here this is Im. There the current is linear, but here the current is non-linear. The current is of sinusoidal shape. For that sinusoidal, I am taking the maximum value of the sinusoidal, I max. So that's why there is some confusions between them here. So simply note down, this is simply Im. Okay, please don't worry. So 60 Im divided by R, and again cos pi by 2 cos theta divided by sin theta. Okay, and again H pi is equal to Im divided by 2 pi R cos pi by 2 cos theta divided by sin theta. Somebody may have a question like whether you have to remember this and all. No need to remember. No need to remember E theta, H pi and all. Just for practice purpose only we are writing here. Even for HC and dipole also, you no need to remember E theta and H pi value and all. Finally, conclusion is important. Okay, what we are concluding from the. Okay, so this is E theta and H pi. But one thing is important here. You just observe this depends on 1 by R, and this also depends on 1 by R. So that means what? Radiation field, far field. So that means I have neglected the near field. Okay, I have neglected the near field because I know only far field is important. That's why I have neglected all the field, all the near field. Okay. Then finally, the radiation pattern depends on some complicated function. Previously, it was depending on only sin theta. Now it is depending on cos of pi by 2 cos theta and also sin theta in the denominator. So when I draw the radiation pattern, then and again I may, that radiation pattern really depends on both the numerator as well as the denominator, because I do not know where the maximum goes, where minimum comes. Okay, so then once if you calculate the total radiated power, okay, and again this consists of derivations. The total radiated power omega r is equal to 1 by 2 theta h pi, or otherwise I can write 1 by 2 integral e theta h pi. Okay, like this also you can write. Then finally, this is simply is equal to I square RMS into 73. Okay, then as per this formula, I square RMS, this I can write it as R radiated. Then the radiation resistance here is 73 ohm. This is very, very important. So what is the radiation resistance of lambda by 4 dipole? Okay, for lambda by 4 dipole, the radiation resistance is, okay, 73 ohm. The radiation resistance is 73 ohm. Okay, so radiation resistance for lambda by 2 dipole antenna, the radiation resistance is 73 ohm. So and again E theta H phi, you know. Next, what is lambda by 4 dipole? Next, for what is lambda by 4 dipole? Okay, in some cases we will have a dipole like this because simply only one half of the half wave dipole, simply lambda by 4 alone, and remaining thing is grounded. Okay, when I have a lambda by 4 dipole antenna, that means what? I have neglected the one portion. Okay, ground portion I have neglected. Okay, this portion I have neglected. Okay, I am having only 1/4. Okay, lambda by 4. When this is lambda by 4, and again what is omega radiated? The omega radiated is equal to 36.5 I square RMS. So when it is like this, then what is the radiation resistance? The radiation resistance is 36.5 ohm. This is very important. For lambda by 4 dipole antenna, the radiation resistance is 36.5 ohm. Then the main important thing is, what is the radiation pattern? What is the radiation pattern? If it is azimuthal means what, sir? Horizontal plane. Definitely, even if I neglect that section, definitely my horizontal plane radiation pattern will not vary, because if I go anywhere on the horizontal plane, I will still see the line, because you fix the line, you go around the line in the circular manner, definitely you will see the same line. There will not be any difference. That means what? My radiation plane in the horizontal plane will be circle only. But once if I go up like this, upward direction, then actually when I am here, I may see some antenna. But once if I go here, finally if I go here, I will not see anything at all point. But I cannot really go here because this is the ground. So I have a flexibility only go in the upward direction. So when I draw the radiation pattern for elevation, that means for vertical plane, when you draw the radiation pattern for vertical plane, I will have radiation pattern only in the above. Below the ground, I will not have any radiation. Only this is radiating only in the only above the ground. It's not radiating below the ground. So this is the radiation pattern for the lambda by 4 dipole antenna. Now I am asking you one question. I am having some power, say some 10 watt. I am feeding that power to lambda by 2 dipole antenna as well as the lambda by 4 dipole antenna. Which antenna will have more directivity? Question Purida sir. With this question I will stop. This is my last question. I am having some power. I am feeding that power to lambda by 2 dipole antenna. Same power I am feeding it to lambda by 4. First lambda by 2 and the lambda by 4. Which antenna will have more directivity? சொல்லுங்க. இந்த ரேடியேஷன் பேட்டர்ன் டயக்ராம் வச்சே சொல்லலாம். அதனுடைய ரேடியேஷன் பேட்டர்ன் எப்படி இருந்தது, இதனுடைய ரேடியேஷன் பேட்டர்ன் எப்படி இருந்தது? Which will have more directivity?
Lambda by 4 dipole, sir. Lambda by 4, sir.
Yes, very good. Yes, very good. Because lambda by 4 will have more directivity because it is not radiating below the plane, only it is radiating in the above the plane. That's why lambda by 4 dipole will have more directivity. It may look something strange because the length is decreased, but still the directivity is increased, but because it's radiating only in one direction. Okay, it's not radiating below the plane, horizontal plane, it is radiating only above the horizontal plane. Then later I will write the directivity of both lambda by 4 and lambda by 2. Then you can compare which one is having more directivity. The directivity of lambda by 4 is 2 times of directivity of lambda by 2 because it's radiating only in the above the plane, but whereas lambda by 2 is radiating in both above the plane as well as below the plane. So that's why the directivity of lambda by 4 dipole is 2 times of the directivity of the lambda by 2 dipole. Okay, lambda by 2 dipole. So in the next class I will write that. So finally the radiation resistance of folded dipole. One more dipole is there, folded dipole. Okay, see what is folded dipole? Anybody where you are using, you know?
TV, sir.
Huh?
TV.
Yes, TV Yagi antenna used in TV Yagi antenna. Okay, I think you might have seen the structure like this, like this. Dipole அதில் கனெக்ட் ஆயிருக்கும். ஸோ இதான் வந்து folded dipole. Then what is the radiation? Again, why we are using folded dipole and all, that is different concept. Okay, just try to find out instead of dipole why we are using folded dipole in Yagi antenna. But one important things I will tell you, the radiation resistance of folded dipole is, okay, again this folded dipole antenna will have the radiation resistance of 292 ohm. So radiation resistance of folded dipole is 292 ohm. Roughly remember 300, then that's 292 ohm. But why we are using folded dipole as compared to ordinary dipole? Already ordinary dipole is there. What is the problem there? Why we are using folded dipole in TV Yagi antenna? Just to try to find out the answer. Okay, so with this I will stop. We'll continue on tomorrow evening.
Sir, one doubt, sir.
So physical resistance, it is a imaginary resistance. Okay, radiation resistance physical antenna எங்கேயுமே இருக்காது. புரியுது என்ன சொல்றேன்னு? Radiation resistance is not a physical resistance. It is a fictitious or imaginary resistance. Imaginary resistance. Radiation resistance naale physical resistance கிடையாது, imaginary resistance. Then why we are using this imaginary resistance? And the question தான் நம்மளுக்கு வரும். Then because you know what is the total power radiated, that is somehow depending on I square. Then I am just comparing with the circuit analysis. I am comparing with the circuit analysis. It is purely imaginary resistance. It is purely imaginary resistance, but it is giving you the ability of the radiation radiated power of the antenna. Okay, it is imaginary, but it still gives the properties of the antenna. Property means what is the ability of the antenna to radiate the power. What is the ability of the antenna to radiate the power? அதனால radiation resistance அதிகமா இருந்த antenna அதிகமா radiate ஆகுது கம்மியா radiate, that is another concept. Okay, then again if you increase the length of the antenna, you may see here the once if you increase the length of the antenna, the radiation resistance increases, then radiated power increases. But actually that is not true, because radiated power is in your hand. Whatever the power that you are giving, that only the antenna will radiate. That is finally denoted by some resistance. Okay, radiation resistance. Okay, so again it is a imaginary resistance. Okay, it is a imaginary resistance. அதாவது என்ன சொல்ல வராங்கன்னா, இது படி ஏன் இந்த கான்செப்ட் இருக்கு அப்படின்னு பார்த்தீங்கன்னா, இங்க ஒரு ஆண்டனா இருக்கு. ஓகே, you are giving some input power. Again after loss some power goes here. After loss, again during the conversion process also loss may be there. Again reflection loss, some other loss may be there. Then finally it is radiating some power on the free space. Okay, say if you are giving 100 watt, okay, it's radiating 99 watt on the free space. So then what they are trying to compare here is, you are giving current also. You are giving what? Current. Actually you are giving current. You know you are radiating 99 watt. Then they are replacing this antenna. Okay, instead of antenna, what they are imagining, simply they are imagining you are having a resistance, you are giving some current. Okay, that current, again you know the resistor can dissipate the power. Okay, the power dissipated by this resistance as well as the power given by this antenna, both are same mathematically. That idea only they are giving, but it is not a physical antenna. Okay, it is a fictitious value, fictitious resistance value. Okay, not physical resistance. Physical resistance கிடையாது, imaginary. Yes, imaginary only. That is for analysis.